Today we are going to discuss how the principal quantum number is used to determine the electron arrangement on the atom. Electron arrangement is just actually meaning how electrons are arranged on an atom. And right before us we are having the structure of an atom. As we can see that an atom is made up of the nucleus, which is the central mass of the atom. Then we also have the energy shells. Energy shells are around the nucleus, and it's on the energy shells where we can see that we are having electrons. Then inside the nucleus is where we can find that we have the protons and neutrons. Yes, protons and neutrons are inside the nucleus. You can see that how electrons are arranged on an energy shell, according to what we have here, is a unique arrangement, because we can see that on the first energy shell we are having only 2 electrons. Then on the next energy shell we are having 8 electrons. Then the next energy shell, which is actually the third energy shell, we can see that we are also having 8 electrons. When we come to the fourth energy shell we are having only 1 electron. But why is it like that? Well, the trick is in principal quantum number, which is also abbreviated as n. So what is principal quantum number? Let's try to think of principal quantum number as the distance of the energy shell. The distance of the energy shell from the nucleus. Because if you look at the structure of the atom we are having here, we can see that the first shell is the one closest to the nucleus, and then the last shell, according to our example, the fourth one, is the one farthest from the nucleus. We have one which is closest to the nucleus, and then there is one which is farthest from the nucleus. And when we are looking for principal quantum number, I've told you that it's abbreviated as n. We count, it's just a matter of counting. The principal quantum number of the first shell is 1. The principal quantum number of the second shell is 2. The principal quantum number of the third shell is 3. And the principal quantum number of the fourth shell is 4. So how does principal quantum number help us to know how electrons are arranged on the energy shells? Electrons are arranged on the electron shells according to the formula 2n squared, where n, I've already told you that n is principal quantum number. That this explains why the first shell can carry only a maximum of 2 electrons, because it is 2n squared. But for the first shell, the value of n is 1, because the principal quantum number of the first shell is 1. So in other words, it's just a matter of substituting n with 1. And what do we come up with if we press our calculators? 2 electrons. So in other words, the first shell can carry only 2 electrons. What about the next shell, the second shell? Again, it's the same formula, 2n squared. And we can see that the second shell, its principal quantum number is 2, meaning we are going to substitute our value of n and we are going to write 2 instead. So when we substitute our value of n, 2 squared is actually 4. Then times this 2, we come up with 8 electrons. So the maximum number of electrons that can be carried by the second energy level is 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. What about the third? The third is, again we are going to use the same formula, 2n squared, which means that instead of writing n, we are going to replace it with the principal quantum number of the third energy level, which is 3, and we have 2 times 9, which is actually a maximum of 18 electrons. This formula actually is helping us to know the maximum number of electrons that can be accommodated on each energy level. This means that the first energy level can accommodate only a maximum of 2 electrons. The second energy level can accommodate 8 electrons. The third energy level can carry up to a maximum of 18 electrons. What about the fourth energy level? Again, it's the same formula, 2n squared. But for the fourth energy level, the principal quantum number is 4, and because the principal quantum number is 4, meaning the fourth energy level can carry a maximum of, because 4 squared is 16, then times this 2, meaning the fourth energy level can carry a maximum of 32, electrons. So a summary of what we have been talking about: the first energy level, which has principal quantum number 1, can carry a maximum of 2 electrons. The second energy level, which has principal quantum number 2, can carry a maximum of 18 electrons. The third energy level, which has principal quantum number 3, can carry a maximum of 18. The fourth can carry a maximum of 32. The fifth can carry a maximum of 50, and so on. They just continue. So let us look at some examples of how electrons are being arranged according to the principle we have just understood. Before me, I'm having the atomic structures of two elements, lithium and magnesium. For lithium, we can see that the first, because we know that the atomic number of lithium is 3. What does that mean? Lithium has only 3 electrons, and because lithium has only 3 electrons, that means that if electrons are to arrange around the nucleus, it means that the first energy level can carry only a maximum of 2 electrons, because the first energy level has principal quantum number 1. And because it has principal quantum number 1, if we substitute 1 for n, we realize that it can actually carry a maximum of 2 electrons. And because the first energy level has carried 2 electrons, out of the 3 electrons, 2 have already been accommodated on the first energy level, leaving only 1 electron looking for space, and that electron will come and occupy a position on the second energy level. So that's how we come up with the atomic structure of lithium. Same idea with magnesium. We can see that for magnesium, which has 12 electrons, magnesium has 12 electrons, and that means that the first energy level can carry up to a maximum of 2 electrons. Just because the first 2 electrons have already got space, it leaves us with 10 electrons still looking for space. And these 10 electrons means that the next electrons cannot occupy a space on the first energy level, but they'll occupy space on the second energy level. And the second energy level can also only accommodate only 8, because it's the maximum it can carry. And because the maximum it can carry, it leaves 2 electrons without space, and these 2 electrons will come and occupy a position on the third energy level. So that's how we come up with lithium and magnesium, or the atomic structure of any element. For example, if we even think of another element such as oxygen, oxygen has 8 electrons, and because it has 8 electrons, the first energy level can accommodate only up to a maximum of 2 electrons, and when 2 electrons are accommodated on the first energy level, it means that 6 electrons have not yet been accommodated. And because 6 electrons have not yet been accommodated, these 6 electrons will have to look for space on the second energy level. And on the second energy level, we can accommodate all the 6. Why is it possible to accommodate all the 6? Because the second energy level can carry up to a maximum of 8 electrons. So meaning all the 6 can be accommodated on the second energy level, and so on and so on. So before us, we are having an exercise: draw the atomic structure of the following. We are going to draw the atomic structure of nitrogen, we are going to draw the atomic structure of sulfur, and we are also going to draw the atomic structure of potassium. The answers and explanations will be given in the next video. Thanks for tuning in. This is Kagenda Kenneth for the Kisembo Academy.